my presentation today is ensuring quality in the design and installation of hoisting system prior to shaft construction. So I really want to focus today on that before shaft construction piece. So obviously initial before shaft sinking. We will discuss a bit about operations and obviously your future production line. However, I think really today, instead of maintenance, it'll be more focused construction. A brief agenda for today, we'll look into a background. I think that'll really set up the session quite well. You know, the following two presentations, it's always good just to dive into the past 2 centuries of hoisting. We'll then talk about the design focus, onto construction, so the planning, a bit about maintenance, and then finally the commissioning and operational handover for the maintenance side. And then final considerations at the end. I will try and finish quickly, so there's 5 minutes for questions. So the background on the slide right there. So really, I think some key things to talk about. The advent of steam obviously brought around a whole new aspect of hoisting. When we look at some of early technology, the man engine, for example, being from Camborne School of Mines, it was well within the heritage of Cornish mining, and really introduced different transportation means for the sector. When we saw the Levant disaster, 31 miners tragically killed in 1919, that's when we really saw a shift towards safety. And over the following decades, we keep seeing that push through the sector, especially with hoisting itself. It is safety critical at the end of the day. We now see a lot of change, safety integrity levels, especially in Canada. It's quite an interesting shift. For myself, Europe, sill rated systems are pretty much standard, same with Australia. But again, Canada is still relatively new. From my end, on the shaft sinking side, we don't really see that. It adds complexity, a bit more cost, and schedule impact, obviously. So the key question when designing a system, your basis of design is how many tons a day? That's driven from your client, from the operator, and really defines that user requirement specification. Built into that will be some of the key questions, are you even going to go hoisting? Haulage, whether it's conveyors, trucks, this is all part of those big questions and CapEx, obviously. With regards to the base of design, legislation is written in blood. We all know the famous mining disasters, especially when it comes to hoisting. We don't need to talk about too much. We've seen some large incidents in the past few years, in fact. So that really is key to everything we do as a design team. I mentioned still rated systems for future technology. Also, upgrading PLC systems, automation, braking systems. These are all considerations, not just for the client, but also for the designers. With regards to the shaft sinking phase, it's very expensive. This is all CapEx with very little gain. So you're looking at about $100,000 a day, 24-hour shift. So every day you aren't sinking, you have downtime, whatever it might be. That's a massive detriment, not just to the client, but also to you as a contractor on site. Ensuring you have that quality before the construction means the legacy of that hoist can be there for the life of mine. Again, look at Canada, look at our hoisting setups. We have hoists that have been in place for 60 plus years. In the Sudbury region, you have mines with a 20-year mine life, and here we are 60 years later, we're still welding shells, we're still upgrading hoists. So it should, not just new hoist or replacements, but that quality has to be there from day one. So you do have multiple stakeholders involved in the design process. You have your third party, your client representative, you have your contractor, ourselves who will do our own design and hoisting systems, working closely with the client. Then you have to pull in the third parties. Your hoisting engineer sign off on all equipment, the OEM to sign off. Everyone has a piece to play in that system. I think what's really key with the design and review stage is the coordination between disciplines. We see it a lot where your mechanical, electrical, structural don't necessarily communicate. And that's something I like to do from day one. Who is in charge of what and who can drive that change properly? I mentioned HVAC here. It's always key. Your hoisting system brings in huge heat loads. And when is that considered? Generally at a later stage. So considering that on day one with your water for cooling requirements, electricity loadings, do that as quickly as possible. Another one is temporary versus permanent. Add in that contingency. With that technology change that we see, there's a lot of innovation, a lot of change in the sector. So So certainly for myself, I like to add that budget contingency. When you think about a hoisting system, 2 years for fabrication, you even get change in those 2 years. So you carry that budget contingency that ensures not just quality, but also potential innovation pieces in your design. Management of change is key, and I don't think I really need to say that in this room. Not just design, but also construction and fabrication. Managing not just the budget, but also the design interface. When you change something from electrical, is that impacting mechanical? Is it impacting structural? That also goes from the installation standpoint. When you start installing, you need to change things with the foundation works, with the hoist house itself, your overhead crane. You might not be able to lift your shaft and drum together. So do we need to revisit that and look at some of the procedures that we have in place? One of my other favourite sayings is, the pen is mightier than the sword, especially in this day and age. We've seen a shift over the last half a century. We've gone from legacy hoists with not much documentation to now we have to document everything. Not just for the client, for the contractor, for safety, from a legislative standpoint. So making sure that management of change is captured, documented for handover is extremely important. You have to have a structured process. So the planning side, obviously is all driven from your project management triangle. Schedule, quality, budget. There's multiple examples where we haven't followed these 3 key processes and we've had issues. Look at the Challenger disaster, for example. Sequencing and craneage, are you going to bring one mobile crane in for the whole project, or are you going to stagger the deliveries? Craneage is expensive to mobilize. You want to bring in a 500-ton crane, you're looking at $40,000 in mobilization alone. And that's before you go to Northern Ontario where you don't really have road access. Again, we talk about contingency, carrying those budgeting costs and quality costs. Winter installations. I can't tell you the amount of times that I've installed hoists with sideways freezing rain. I don't know what it is about our sector, but we only install hoists in winter, never in summer. And that goes to be said with the hoist house itself. You're going to install the hoist before the hoist house or after. Personally, land hoist first, rough set, build hoist house around. It's quicker, it's easier. However, you build the hoist house first, put your mobile or your overhead crane in, and obviously your installation's a lot warmer, but also faster. Fabrication itself, again, this goes back to that big quality piece and due diligence. So factory acceptance testing and inspection test plans. Always make sure there's a clear plan before the factory acceptance test. You want to be turning up to the supplier's fabrication facility with a clear plan with all the stakeholders aligned. Never ship anything without a sign-off before release. Ultimately, from the client and you as the contractor. I like to use supplier document requirements lists. When I scope out a system, you'll define the documentation before you even place a PO. At that point, everyone is aligned with the documentation requirement, checklists, leak tests, pressure tests, whatever it might be. That way you can hold accountability to the supplier, and also to yourself as a contractor. If you have a change in your resourcing on project, everyone knows what the expectation of documentation is on the supply. Visiting shops obviously goes without saying. Trying to push engineers, quality teams onto the shops to understand your subs is key. So in Ontario, it's slightly different to elsewhere in the world. Obviously, construction permits are very important before foundation construction. You have to consider how long that takes. You can't just construct a hoist house straight away. You have to get the inspections, the city have to come, it takes time. Talking a number of months in some cases. Wobble tubes, fairly standard throughout, you get the tolerance, again it takes away the risk at an early stage. Especially when you start casting straight in with the bolts, it's challenging. Especially from a survey standpoint, your machine has X amount of tolerance. You want to be aiming for the +3, +2 millimeter tolerance on that. Obviously we work very closely with the survey teams from the installation, and we do talk about that later in the presentation. Again, winter installations. How are you going to keep your concrete hot and moist? Certainly in terms of shrinkage cracking. You're doing mass cores for hoist house, 800 cube plus. It's really hard to get trucks available to continuously bore in one day. And finally, the field changes. Mentioned it before. Management change, so key. I push the engineers on site, the site engineers, always to track everything and stay on top of the construction. It's not just lessons learned, it's also, key quality. So given installation itself, obviously there's lots of design considerations. Shaft sinking, future works very, very different. I'm a shaft sinker, we want quick installations, simple installations. That doesn't work for permanent phase, especially with regards to mechanical. Again, we mentioned the factory acceptance visit, the measurements taken, turn up to those FATs with a clear plan with the mechanical team. Ideally, you have a maintenance team who are both mechanically and electrically versed. And again, as-builts. We talk about hydraulic tubing for your brake system. How many hoists have you seen where you don't actually know the hydraulic routing? Having to go and as-built it yourself on old prints that don't really exist. So capture that all at the stage of install. Electrical obviously always comes last. Everyone else gets in there first. But we try to be proactive. Get electrical in as early as possible, and instrumentation. When you're doing your construction control systems, your safety control system designs, that is when the operations team need to be involved to talk about future interface between the two groups. It's very easy to design your track limits, your shaft obstructions, whatever it might be, without considering what the shaft might actually look like in 20 years. Operations will change, but also procedures will change. So consider that at the design phase, at construction, and then carry that contingency throughout the build. Another big important one to mention for electrical, especially within Canada, obviously your CSA and ESA certification. You look at your drives, look at some of your control systems, all come from abroad. Not only do you have the weeks of transportation, but also the requirements for in-country electrical certification. That can take time. You might also have to do rework. So make it very clear, we talk about the supplier document requirement list, staff contract, you are supplying to Canada, we have this certification that you must adhere to. And future proofing. Electrical technology is changing the most out of anything I see in hoisting, I guess other than maybe your instrumentation. So make sure you carry that fact, future proof your design, see what might happen. So survey, again, key construction, always oversee. Every construction project that I've witnessed, survey is not fully understood and it's always a bit of a patch job. With survey, we have both old and new techniques. We still set out hoists how we did 100 years ago, but we can make it more efficient with new technology. So your piano wire, your string lines are great. Your construction team who have no idea what a total station is, can work off that. You rough set. Total station will make it more efficient with certain crew. Especially with your digital levels, we did a bit of playing a couple of years ago with our winch installs. Actually found the digital levels in terms of accuracy were up there. Some of the best tolerances we've seen out of any installation. Obviously there's a bit of concern how accurate digital level is, but it was fantastic. That's just an LS10. When combined with the old style techniques, it's great. You still can't get away from the machinist level. So your mechanics will always have that final piece to play, but you can turn out reports quickly, you have a bit of confidence in your survey, especially if you're using a total station. Third-party checks, always key. Survey in general, get your third-party contractor in, do a control check, you're only as good as your primary control. Especially with surveyors these days, you see a big difference between a surveyor and someone who can use a GNSS, and they're two very different things. So QA versus QC. Again, two very different things. Underline a very important piece. The best engineers are the ones in the field. How many times do we see people who don't visit the shops, don't visit the construction? The engineers, certainly on my teams, I like to push out. I expect them to be covered in grease by the end of a road up. I expect them to understand how to torque a bolt. To be there helping lift the sections of a winch in place. It's so important not just from lessons learned, but also from understanding the process itself. A foundation installation, from a quality standpoint, talk about concrete, talk about aligning. There's so many different moving pieces. If you aren't in the field, you won't necessarily see that at all. It's also key with QA and QC, the difference between off-site and on-site. There is a change. There's a maturity growth in the installation sequence, and you have to adapt. We've defined this all at the start, don't forget. With our scope of work, with our pre-planning, we know what we need to do at each stage, and we take everyone on that journey. Commissioning is obviously when it gets quite exciting. Start livening up equipment. Again, livening up notices is your documentation. I've seen a lot of examples. We've been proud to equipment, to transformers, to drives, without properly checking things. There's a loose wire, a wrong termination somewhere, and you have issues, more rework. Make sure there's a multi-party sign-off before you go to that commissioning stage. I like to do a two-phase approach. Commissioning sign-off and operations sign-off. All key stakeholders, and avoids the finger-pointing blame game. With the commissioning itself, the pre-commissioning, you get good opportunity to train your hoist operators as well. During rope up, you can look at things like motor torque values, you can really understand how the hoist functions, or the winches, and you get stick time for the operators as opposed to all learning remote offsite on a simulator. The schedule is critical for commissioning. You have to hit the time that you say you're going to. And again, through that proper planning with the right people in the room, you can ensure that the quality is carried through to commissioning. MOC comes up again. Management of change is so important in this day and age. So maintenance is definitely important to touch on. There are some proactive activities you can do during the construction before you start the shaft sinking work. Certainly with regards to oil, right now you can add additives to the gearbox oil, so your gearbox, not only do you have shipment and proper oil for storage, but also for future work. So it's a nice easy transition. Filling up an oil box, a gearbox for a hoist is expensive. So you want to try and maximise your cost. And if you can have that oil, that would be for storage, and the hoist is sitting around for X amount of time before you install. And then you can actually go into operations with that. You're saving money. We standardise all our oil and lubricants across our sites. So hoisting, some of the plant equipment, your fleet, and also greasing for bearings and whatnot. So the suppliers, you can work with them quite easily. They can make you a nice regime and work with your maintenance team. Baseline measurements, so your vibration, your temperature, all those proactive measurements, you need to be able to come back and compare to that. When you have an incident, you have a maintenance issue, you don't actually know what you're measuring against. This could be years down the line. With those baselines, you always know what it should be. Again, I've seen that a lot of times where you don't have baseline measurements and you pick up a random vibration somewhere, certainly with electrical, and it's a nightmare. Storage requirements, again, very important. How are you storing equipment? Do you have rotation needs? Do you need to access the crates? Some crates you can park for multiple years, you never have to go to them. Some crates you have to go in every 6 months. So again, that consideration of on-site versus off-site storage is very important. And I see a lot of times where people don't consider the storage requirements. And again, you end up replacing equipment only 2 years down the line. Hard copy packs versus electronic packs, again, pen being mightier than the sword, keep both. What I like most about the hard copy packs, you get an MOL visit, they want to go into your hoisting system, you hand them a pack, 600 pages, they're made busy for a good few hours. But you follow up to the client with an electronic pack, you've got your records yourself. That ties into document control processes, make sure it's documented properly. So some final considerations just to summarise what we discussed today. So obviously the design considerations are so key. Are you sinking setup or permanent setup? Try and carry a sinking setup through the life mine as much as possible. Use your double drum for sinking. Use winches that you can transition into a second shaft or you can resell. Obviously they're both different, they have to have their different requirements. You don't want to be tied to your permanent means, so with your control systems in the sinking phase. Fitness for purpose. Make sure your design gives the end user what they need. If they need 3,000 tonne a day, don't give them a hoist that does 6. Don't give them a hoist that does 2. Design with that contingency in place for when that mine keeps going 60 years later, which it probably will be. Teams must involve construction and operations early on. That is where the knowledge is, ultimately. The maintenance teams are the teams of the future, so design with their needs in place. The regulatory requirements, I don't really need to say. We know how important that is. We're all constantly in communication, but work with the inspectors. We're very fortunate in Canada. The inspectors work closely with the teams that are open for innovation. Be involved with the board discussions and future change. No, I think a good example is dogging. Look at the change in legislation now with steel guides versus wooden guides. We've already seen that in Europe, and now it's slowly moving into Canada. Legacy older equipment must be properly maintained. We all know that, especially when the hoists are running for that longer duration than they were ever planned for. So future-proof where you can. And then finally, engineers in the field is the most important thing. We all have a responsibility to push the future engineers, to push and obviously ensure that the sector has the right people in 10 and 20 years' time. There's a big age gap, a big trades gap at the moment. So get people out in the field, the exposure where they can to understand the lessons learned and what they need to do. Obviously just some key references there. I recommend a look at some of them. Thank you very much. So if there are any questions.